Hello, I'm back again. I'm continuing our discussion on speed problems. In the first part, I just gave some ideas and some general things. Now, I will be doing some specific things which are, you know, frequently occurring in all competitive exams. So, let's see. Uh, I will give you some hints on how to solve the problems on boat. These are very interesting and funny, provided your basics are strong. Before I take one example only, which I feel is more than sufficient to teach you all the things involved in this board problems. But before that, it's necessary that I give you some solid concept which will be used in the solving of board problems. So that is concept of effective speed. See, please don't confuse the concept of effective speed with relative speed, because I'm not dealing with relative speed concept in this video. I want to make it clear. When two trains are running in the same direction, when two trains are running in the opposite direction, there we use a concept of relative speed. But in both problems, we are not using the concept of relative speed. We are using the concept of effective speed. So what is effective speed? I can make it clear, because this part is very important. Then one problem sufficient. Therefore, you have to be alert. Catch this concept. So what is effective speed? Let's say x is speed of boat in still water. And y speed of stream. This word is very important. Imagine water is still. Then with whatever speed you travel, that is called x. But in reality, stream is not still. It is moving with some speed. Therefore, x will be there, y will be there. Now, please understand carefully. Effective speed when you are traveling downstream means if the stream is running like this, you are going in the direction of the stream, therefore downstream. So what will happen is this is not mathematics, this is a common sense. Say if your x is 10 and y is 1, so what will happen when you are going downstream? Both will be added. So x plus y. So it's always easy going downstream. It is always difficult to go upstream because the stream is opposing you. Now, the other one will be understood easily if you understood this. So here what is happening is, if the stream is running in this direction, your boat is going in the opposite direction, so we say upstream. Here you are going in the same direction, here you are going in the opposite direction. So it's understood that x is greater than y, because if x is lesser than y, then how can you move in the upper direction? You will go in the down direction only. And what happens if x and y are same? Okay. Now, effective speed will be x minus y. I repeat for the last time, because once I am done with this effective speed concept, I am going to take one example which is more than sufficient to crack the problems on board. Effective speed is x plus y when you are going downstream. Effective speed is x minus y when you are going upstream. With these things in your mind, you will find these problems easy. Let's see. Let us say a boat is going from A to B. We'll call it downstream. Then it comes back. That means it will be traveling upstream. So what is given here? What is unknown? Let's see. It is given that speed of boat in still water is 10 kilometer per hour. Speed of boat in still water is 10 kilometer per hour. And it is given that total time taken for going from A to B and then back B to A, total time is 5 hours. You can easily guess now. The only unknown is what is the speed of the stream. What is the speed of the stream? Now, what is interesting is I could have solved 3 problems, but I prefer solving only one. Otherwise, they will ask only on downstream, they will ask only on upstream. Therefore, I thought it is wise to go for both in one, 2 in 1, 3 in 1, you can say. Now, how we can write the equation? See again, this will not change. Distance is distance, speed is speed, time is time. Only thing that's important here is using the concept of effective speed. How do you write an equation? The equation has to be written for total time. So what is the total time? 5 hours. Now say, if you travel 24 kilometer downstream, what will be your effective speed? Your effective speed will be 10 plus y, because 10 is your speed of boat in still water, y is the unknown, which is the speed of the stream. Now you are coming back, you are traveling the same distance, 24 kilometer, but this time you are going upstream. So I told you that now the upstream speed will change. This 10 remains same. It is understood that it is remaining same, but this effective speed has to change. Why? Because you are going upstream. You are going upstream. So write it as minus. So what is the total time? 5 hours. Now I know what's going on in your mind. Those who are comfortable with mathematics, they will think that this problem should not be attempted because I am in a trouble. Why? If you see the LCM, it's like a plus b, a minus b, and LCM of a plus b and a minus b is a square minus b square. That means you will end up in a quadratic equation, and then all those commerce and arts students will say, sir, I am done with that. Wrong. Remember, examiner is not testing you for your simplification skills, he is testing for your smartness. So what I strongly recommend is, because I come from engineering background, for me it is very easy, but I share one secret with you. Enjoy it. Don't get into the trouble of solving. Don't find LCM. Take the option and finish it. We call it plug-in. I will teach you now how we can do that. Let us say there is 3 here. Let us say 2. Then we can be given, any number of options. If you are quick in calculation, you will see that how easily we can eliminate the options if you know what is the correct equation. If you put 3 here, 10 plus 3, 13. 24 divided by 13 is a fraction. 24 divided by 7 is also fraction. And even if you roughly work out, I don't think it will come to 5. You have to be quick in that. That's why the numbers given are very easy numbers to deal with. Otherwise, imagine if we had given 340 here, then some three-digit number. No, examiners also are aware of the fact that there is a pressure of time. Therefore, they will give some numbers which are easy to handle. So now, come to this. What is 10 plus 2? 12. 24 divided by 12 is what? 2. 10 minus 2. What is 10 minus 2? 8. 24 divided by 8 is 3. Did you get it? Total time is 5. So, my friends, the answer is 2. So, what I wanted to stress here is not the art of simplification or finding LCM. Just be content with the equation. Once your equation is ready, plug in. This will take less time even if you exhaust the options. No? The time you would have spent in simplification compared to that, this time will be less. I hope you are comfortable with this. I'm winding up my discussion on speed with a very interesting problems on what we call as circular race. Okay, in fact there are linear race problems also, but because of time constraint and space constraint, I would like to discuss only these circular race problems. See, these are really interesting, provided you understand. Normally, these problems are like, say there are two persons, A and B. There can be three persons also. First we will talk about two persons, and then if time permits we can go for three persons. The circumference will be given. Whatever is the circumference, one round. Then you will be given the speeds of the two runners, say A and B. You will be given the circumference, there is one track, and you will be given the speeds of the two runners. And two questions will be discussed in my discussion here. Two typical questions. Right now what I am telling is I am not telling anything. What is that I am going to tell? That illustration I will give through one example, but just I am building up theory. Then we will practice it. Given the circumference and the speeds of the two runners, two questions will be asked. First question is, after what time they will meet first? After what time they will meet first? Second question is, when they will meet at the starting point for the first time. If you are beginner to this topic, your head will reel, because it looks like first part and second part of questions are same. They are not same. So the best way is, instead of discussing the theory, go for one example, and there whatever tricks I have, I can share it with you. Okay. In our problem, it's given that the one track circumference is 500 meter. We have two runners, one with speed of 20 meter per second, and other person 25 meter per second. Okay. Two questions. You are asked to find the time when they meet for the first time. This is also first time, the second part, but it's asking at the starting point again. At the starting point. I will go slow here because if you are not familiar, you may find it too much. I have patience. Now, second part can be made interesting. First part requires a bit of analysis, but quickly I will just jump to the steps only. You can do it mechanically. So what you do is, find the relative speed. I told you earlier, relative speed and effective speed, these are two different things. Effective speed to be used in the context of board problems, but here we are talking about a relative speed. What is relative speed? If two persons are running in the same direction, their difference will be relative speed. If they are running in the opposite direction, their sum will be relative speed. I repeat, if they are running in the same direction, difference will be taken as a relative speed. If they are running in the opposite direction, sum will be taken as relative speed. So how do I use that relative speed concept here? To answer the first part. Difference between 25 and 20 is 5 meter per second. Now, all that you have to do is divide that 500 by this 5. 500 is length of one track. This is the relative speed. So it will be 48 seconds. So my dear friends, be happy, answer is 48 seconds. What happens after 48 seconds? Both runners will be meeting for the first time. But how this is different from the second one, I'm coming to that. Have patience. To answer the second part of the question, what you have to do is very simple. This 20 is there and 25 is there. Find the LCM. Find the LCM. And I hope you are comfortable and quick in finding the LCMs. LCM of 20 and 25 is 100 seconds. So celebrate, my dear friends. The answer to the second question is 100 seconds. So what is the difference? I will tell you. When they met after 48 seconds, they were not meeting at the starting point. They were meeting at some other point, which is not the starting point. But after 100 seconds, what happened is, when they started, they were here. After 100 seconds, first time both of them will be meeting at the starting point. To make you understand this one, I can give a bit of explanation. Then I am done with it. Tell me, in 100 seconds, first person will run 5 rounds, right? In 100 seconds, first person will run 5 rounds. And in 100 seconds only, second person will run 4 rounds because he is faster. So what happened? The first one, after running 5 rounds, he was here. And second person in the meanwhile, because he is faster, was here, but he had completed 4 rounds. Therefore, they met after 100 seconds at the starting point. This one is a bit tricky, but right now I don't have time. I can help you in that if you contact me. So it's a pleasure to be with you, and I'm leaving my email ID. I'll write it here, and I'm accessible. Right now I'm enjoying vacation with my son-in-law and daughter in London, and I'm an Indian, and I love interacting with students. I'm writing my email ID here on the board. Feel free to contact me. Gurumath, GURUMATH 61 @gmail.com. So I'll be eager to get any queries or any problems. I will be helping you. Please feel free to contact this email ID. Thank you very much.